Welcome everybody to this month's edition of DevSecOps Live. DevSecOps Live is brought to you by Practical DevSecOps, where I happen to work as a principal security consultant. We're a product security company specializing in consulting for DevSecOps and product security and anything that falls under the sun with respect to all of those terminologies. DevSecOps Live is a monthly event, usually on the Thursdays of the last Thursday of the month, but sometimes it's on some of the other Thursdays in a week. We have been doing a lot of sessions on threat modeling in the past. We've done threat sessions on privacy modeling, threat modeling as code. We've also done software factories in our previous episode. And the next episode is also coincidentally is going to be about threat modeling. But today's topic is about DevOps and threat modeling. Well, it's a question, DevOps versus threat modeling. Well, it doesn't have to be that way. The webinar is being recorded as we speak. All right, I've shut my video off and hopefully that improves the quality of the audio. Thank you very much for letting me know. So, where was I? All right, the webinar is being recorded as we speak. It will be available in our YouTube channels. If you follow us on LinkedIn, the webinar will be available for you on demand. And about today's session, if you have any questions for the speaker, Brooke, please reserve them towards the end. We will use Zoom Q&A, or if you have a question, I will enable a microphone for some of you so you can actually have a real conversation with the speaker today. With that, we have Brooke today. One of the funny things is there was a bio about Brooke that I tried to fit into the standard place where Zoom allows. It only has about 1,000 characters to read. It only has about 1,000 characters to write biography of a speaker for a webinar. But Brooke has done a lot of contributions to the security industry, that it is much more than that. So some of the things, he's a senior fellow. He has authored several books. He's a leader in threat modeling, worked with many corporations whose software that we use today directly or indirectly. Member of IEEE, co-authored the threat modeling manifesto, and there are so much of details. With that, I'm going to keep that short and give it over to Mr. Brook Schoenfield to speak a few words about himself and also to tell us how DevOps and threat modeling can work together. Over to you, sir.
Thank you very much, Maran. And thank you for inviting me to speak. It's always a pleasure to try and help people understand, I hope, and hopefully this will be valuable to you. About myself, I mean, because I've written a bunch of books and do these kinds of speaking on a regular basis, it's pretty easy to find out about me. I mean, presumably we all know how to use a search engine. Just stick my name in and you'll get pages. So I'm not going to bore you with that stuff because it's not why you came. Why you came was to get some, hopefully actionable stuff you can use in your programs. So let's get moving, if you don't mind. There's a lot of talk right now about threat modeling. I just heard. I would have probably designed these slides slightly differently. Maybe I should have checked it out, but that you've had a lot of, this group has presented a lot about threat modeling. Threat modeling as code. I'll bet that was my dear friend Dizar Tarandak. That's my guess, because I love his PyTM, and we'll get to that in a little bit towards the end of this presentation. But clearly, there's a lot of energy around this. And some of that is, the OWASP top 10 for the last couple of years has included secure design, and I'm going to put threat modeling into context with secure design in a moment. So please bear with me. NIST Executive Order 14028 says threat model. You got a threat model or you're doing yourself a disservice. And so there's lots of new books regular webinars, as we just heard, presentations. I do some of them myself. There's the Threat Modeling Manifesto, which came out a couple of years ago, of which I am a co-author. There's a lot of energy about this, but what is it? And is it that important? I hope I'm going to prove to you, yeah, that it is really important. And I've heard this saw for, the last 12, 14 years. I've even seen major people get up on major stages and say, just automate all your security. Is that possible with threat modeling? I'm going to answer that question. I'm going to answer that question in some detail today, which is in a way why I came. The answer is yes and no. And I want to just say philosophically, I have some trouble with the can't we just automate our security? Because in a way, it's saying, golly, can't I just shove this problem, which is thorny and difficult and multivariate, multidiscipline, multi-domain, off onto some tool? And I wish our tooling was at that level. I wish our tooling was better than attackers' tooling and attackers' techniques. But in my very strong and very professional opinion, that is not the situation. So, importantly, we all have to take responsibility for security. We have to understand what it is, and we have to understand what we can automate and what we have to do by hand and why. And I think that's probably going to be the state of the art for a little while further, although the automation, especially in threat modeling, is coming along, really coming along. So, I have high hopes, but just as we still have to write you see no code apps, well, somebody wrote a whole lot of code to make that happen. Just as there's code behind the code, behind the code, behind the code, well, there's some human analysis behind the code. I want to start with DevOps, and I know you're all DevOps people. I'm very familiar with this, so I don't want to bore you, but there's something that bothers me in DevOps talk. And so I put up Redmine's infinite loop. There are lots of infinite loops. They all purport to represent DevOps. And to my thinking, they're wrong. And that's why I put this up here. Yeah, it's all very neat and things keep going around and around and around, but it's linear. If you straighten that out, release comes after, then followed by configure, which followed by monitor or whatever, right? No, that's not how threat modeling works. I mean, that's not how DevOps works. And I just want to remind you as practitioners that while everything may not be in an infinite loop, if you look at the right of this slide, almost everything is happening in parallel. And I couldn't think of a better way to image that. I'm not a graphic artist. This is a terrible graphic, I'm sure. And hopefully it realizes on your screens in some reasonable way. But it's the best I could do because I haven't found what I need anywhere else. So I drew that graphic on the right, bad a graphic person as I am, in an attempt to say, wait a minute, each of these activities, and you could separate the activities any way you like, is happening in parallel. And maybe they're not each infinite. No, we don't always create new ideas, but they're regularly happening. And at the same time, we're regularly planning and we're regularly coding, but we're constantly monitoring what exists. If you're in a CI/CD situation, stuff is getting updated all the time. So we're thinking about configurations and all of most of it's code. And everybody's a coder in the process. And everybody is tied together by the goals, shared goals, and lots of feedback. If you're working Agile, then you have a daily stand-up, and that's an attempt for everybody to get some feedback about what's going on with everybody else, so problems can be surfaced. And it's one ceremony for dealing with that, not the only one, but certainly one that probably most folks are familiar with. And that's the problem here, is that all these things are happening at the same time. So let me just set the basis. To me, that is the nature of DevOps, if you will. And it's more of a philosophy than a set of tools. The tools help us to achieve the philosophy. So I'm not a big one in saying that DevOps is a bunch of tools. No, the tools are our ways of getting into DevOps. By the way, I'm a huge fan. And besides, the most important thing is, this is the way software is built today. Even companies that build hardware and have for a very long time are experimenting with parts and bits of DevOps thinking. So another problem that we have here is we talk about software security, of which threat modeling is the key component, but we don't often sit down and say, what is actually software security? So in an effort to understand what I was designing for, years ago, I wrote some principles. And I learned about principles from the enterprise architects with whom I've had the privilege to work and learn from. And you can't design unless you know what you're designing for. And so I wrote these principles. They're more like behaviors. Let's just be really clear, more like behaviors. And I want to share them with you so that you have a sense of the breadth of what we're dealing with. So obviously, if you ask a lot of people, they'll say coding securely, right? Errors can provide opportunity for attackers or leverage for them. And we know that, everybody knows that. And yes, that is part of software security, to be sure. Implementation errors, try to get rid of them, right? Encryption is a tool we use all the time. And access controls. For the last 25 years, when I have asked people about software security, these are the answers I typically get from people. Coding security, or the tools that we help to use, like static analysis or something, encryption, or access controls. But actually, it's a lot more than that. So I wrote these principles. First, we want our software to be rid of implementation errors with exploitable effects. And that is vulnerabilities. We want them to be rid of that. So that's an obvious, coding security. But we also need stakeholder security features. For instance, if you went to your bank and it didn't have a strong authorization mechanism that kept all the other customers of the bank from seeing your account details, you would not bank with that bank. That's a stakeholder feature. So if anybody ever looks at you and says, oh, security is non-functional, just remind them about the authorization and authentication at their bank. These are security features. So we have to have security features, protect stuff in transit or whatever. Those are features. We have to design those in. We have to think about them and build them. Because today the level of attack is huge, and I'm not going to go into that in this presentation, but sometime if you want to talk about that, just let me know and come back to it. The level of attack is huge. So a lot of our software is going to need to be self-protective, not all of it at the same level. Something you stick on the internet has a lot more requirements than some little utility that you only have on your personal machine. But it's a range. We want to limit the consequences of attack because software fails. That is the nature of software. So let me be perfectly clear, software fails. Can I repeat that one more time? Software fails, including all of our security tools. Nothing is perfect. Therefore, we have to plan for that. I was just doing a threat model with one of my customers. I think I'm a competitor to Marin. And they were having a little trouble with one of the requirements. And I said, this piece of software that we're counting on and doing our best to secure, it could still fail. And then what do you do? And so part of my threat modeling is always to consider that any control I put in there, every control will fail. And then what am I going to do? And finally, and this was brought home very early in my career, if you put an open Linux box on the internet, how long do you think it will take to be compromised? Well, I'll answer my question. Anywhere between 17 seconds and about 8 hours. So yeah. I'll point out, just to be clear, that the bottom 4 principles or behaviors require planning and design. And we figure out what to do with a threat model. That's what threat modeling does for us. Not just today's vulnerabilities, but planning into the future about things that may happen, that we think have some likelihood to happen, bad things that may have some likelihood to occur sometime in the future. We plan for them today by doing a threat model. And basically that's secure design. So I hope I've put the foundation to OWASP's secure design and tied it into threat modeling. Threat modeling is the technique. So when we talk about threat modeling, it doesn't really matter what technique you use to plan. So I've worked with people, teams that do all their design work as they code in parallel. I've worked with teams that do pre-code skeleton or runway. I had a major program that I ran at a tech company where that was our Agile method. We built just enough skeleton to get people going, and then they did the rest of their design as they coded, as they worked on it. That it works fine with that. Some people like to code themselves into a design. You can still threat model. It really isn't in conflict with that. Or a structured architecture process. Maybe you work with one of those, or the famous secret cabal who produced the 250-page architecture that no one ever looks at, and it just sits on a shelf. Yes, that still happens, by the way. I do run into that from time to time. It's not the best way to do an architecture, in my opinion, and not very useful, but yeah, it does happen. And especially at legacy companies that have been doing digital stuff for a long time. So yeah, it'll work with that, but that's the worst. The important thing is threat modeling is part and parcel of building software. It's not some special thing you do on the side that some special person comes in and drops a whole bunch of security requirements, often way too late, on top of you and walks away and has nothing to do with it. No, threat modeling is part and parcel of the process. It's the way we figure out what security we're going to build, just like techniques for figuring out how big a scale we need or what the usability of a piece of software might be. Security is no different. We have techniques, and threat modeling is our technique. And importantly, most of the attendees on this call threat model as a regular part of their life. For those of you who drive a vehicle at any time, I'm going to guess you have a threat model when you get behind the wheel. There are bad things that can happen, and you've prepared yourself, and you now have evasive techniques that you may take in order to accommodate for those. And, I actually don't want to, if you don't have a threat model, I actually don't want to share the road with you. And for people who don't drive, you know, where do you stand when you're on the Paris metro? You have a threat model for this. Where you, which, you know, if you use ride sharing services, do I get into that vehicle or not? You have a threat model. You may not think of it that way, but really we threat model all the time. There are threats and risks we have to deal with, and we have techniques, we think of techniques we'll be using. And if you believe that life is just going to go, you know, may I suggest you start threat modeling, because bad things happen, and particularly to digital systems. Right now, as I speak, bad things are happening to digital systems by the thousands. So yeah, highly likely. Okay, so how does this, let me pull this all together. Threat modeling contributes to our design by anticipating attacks before they occur. This is very important. One of the biggest mistakes out there is that threat modeling is only about what exists today. No, threat modeling anticipates attacks. As I said, it's an aspect of design like performance, scalability, usability, whatever. All the star-ilities, as my friend Isar likes to say. Implementation specifics are identified, and as they are identified, we return to our threat model, as we shall see. Let me define it. This is from the Threat Modeling Manifesto, and I encourage you to go out there. This is such a great collection. Can you imagine 14 really senior practitioners getting together and doing anything except arguing or all standing up and talking about what they think is important? That's not what happened here, nor is it what happened in the Avoided the Top 10 Security Design Flaws. We actually had that book written in about 6 weeks, or most of it. People came to work, and the same was true with the Threat Modeling Manifesto. People came to work. They came to really, really, really try to distill the best thoughts about threat modeling. So I encourage you to go there. And I think this definition is as good as any. I have one that I threw out there years ago. Nobody really picked it up. So let's go with this one. We're analyzing representations of a system. The system might not yet actually exist. It might just be in thought and dreaming. To think about concerns about security and privacy. Yeah, that pretty much captures it. Good enough. Or you could go with Adam Shostak's 4 questions, which we actually quote in the Threat Modeling Manifesto, and he was a part of he's a co-author too. What are we working on? What can go wrong? What are we going to do about it? And did we do good enough job? I mean, yeah, that's threat modeling. Now, I have to say, it's not necessarily trivial, because one of the problems here is you need some architectural knowledge. You need to be able to answer the question of what are we working on in a abstract enough form to be able to think about it as components and functions and flows, which is what we're interested in. Biggest problem I see, and thousands of people have been through my threat modeling classes, the biggest struggle I see is with the what can go wrong. And I'm just going to focus here. I'm just talking about attackers and digital attack. I'm not thinking about things like earthquakes, or there's a lot more that can go wrong, but I'm just going to focus here on digital attack. And what can go wrong? Most people, if they haven't been doing this for a while, have some trouble getting out of just what they know to the universe of what the attacks are. So that's actually one of the biggest problems. And that's one of the biggest problems that things like threat modeling automation can help us get out of the ruts that we understand. into the universe of problems. So that's one of the biggest challenges to threat modeling. Risk rating is very poorly understood. I'm sorry. And if your company is using CVSS, you're doing it wrong. I'm sorry. CVSS was never built as a risk rating. It is not a risk rating. It is a potential severity rating. They are different. And CVSS is not up to the task. There's a lot of research on that. I'm not going to go into that today. I don't have time. But, you know, I have other presentations that are all about that, and articles I've written and books and blah, 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 because it's a very important and big problem. And we need to know when to stop. Did we do a good enough job? Actually, that's not that hard. And maybe I'll just tell you in a moment what it is. But to really bring this home, threat modeling analysis can be brought down to these things. You apply known successful attacks. Okay? We don't have to go out and make up new attacks. Security researchers and attackers do that from time to time. Most stuff that we see is actually variations on stuff we already know about, which is good because it makes planning and threat modeling a lot easier. But new attacks do come around. And you have to account for that. But we use known successful attacks, because I'll just give you this important little piece of information. About 3/4, and research has different numbers here, but about 3/4 of the CVEs, that is vulnerabilities recorded publicly, never get exploited. They're dross, they're unimportant. They don't count. Only about 25% actually ever get used. So, and there are a lot of reasons for that. Again, that's a different presentation. We can go into why that's true, but I'm not going to today. So we look for the known successful attacks, things that have worked, that attackers actually use. And we apply all the relevant ones, because it turns out that attacks and technologies map kind of one-to-one. So every attack isn't possible, as you probably already know, against every technology and every architecture. There are very specific attacks that work against particular architectures. And so that's what we have to know in order to threat model well. They attack at points that the attackers might reach. And then there's some analysis thinking about, well, if they're going to get to an admin interface that's behind multi-factor authentication, what do they have to do? Well, they probably have to compromise the person who actually has that multi-factor authentication, because they're probably not going to be able to do it unless they compromise the multi-factor authentication. That's a possibility. So that's different than an interface that has a routable address that has a nasty remote code execution vulnerability in it, where all they have to do is send the attack to the interface. Very different. And so one of the pieces of analysis here has to do with how exposed and in what way. Then we gauge the potential negative impacts of successful attack, which helps us rate the risk for each attack scenario. And then we figure out the defenses. Now, there is some threat modeling in the world where people don't figure out the defenses. They just want to raise risks. That's probably doesn't apply to DevOps. It applies to consultants and security arms. So I'm not going to talk about it. I'm not interested in that in this context. Always, your threat model should come up with what you're going to do about it. I'm not going to go through this slide because I think folks probably have been through these things. Instead, I'm going to move on and talk about the common challenges. Like I said, which attacks? This is really one of the big stumbling blocks. So often I see people classically, they're comfortable, they understand the architecture, they're ready to start doing the threat model, and very quickly they say, oh, we need encryption here. They haven't actually thought about the attacks. They just know that encryption helps. with certain things. So I want you to back up from controls, defenses, to what why are we putting the encryption there? To what purpose? Because encryption is not peanut butter we spread all over our applications. It has very particular uses. So here's some things. You can use Stride. I find from practitioners that the Stride method, it's only about attacks, by the way. It isn't really a threat modeling method, just to be really clear. But it could help if you're completely new. That's a great place to start because it gets you thinking about bad things. And can someone spoof something to get in here? Once they get in, can they tamper with some data to make it behave badly? And so on through the Stride acronym. But I find practitioners very quickly get, what's the word I want? They very quickly find its limitations and they need to become more specific about the attacks. So, it might help. And I always teach it just in case it helps, but we quickly transcend it in my experience. Next thing is Adam Shostak's elevation of privilege card game. This is great, really great, because it's got a lot of attacks and at least it gives you the universe of attacks or a sense of the universe of attacks that might be applicable. And you can go through the game and see which things apply and which don't. And at least it's a reference that may be useful. University of Washington security cards also are, in that same way, they can provide a greater universe of what to consider. I love the continuous threat modeling secure developer checklist. It's a little different. It doesn't really think about the threats. It thinks about the design patterns that come up and what you should do about it. So that's a great place to start. It's a little bit different view, but it's terrific. It's a free resource. Get out there. There's tons of OWASP documentation. Yeah, go beyond the top 10. Tons of OWASP documentation. It's very good. A lot of times I find learners start with a tool. They start with one of the open source tools. And I've listed a bunch here for you. There's obviously Microsoft's venerable threat modeling tool, Fragile. I'm not sure how to pronounce that, but I've looked at it. It's very good. There's PyTM, which is threat model as code, and there's a bunch of stuff already written in there and people contributing to it. So that's very powerful. And in a DevOps environment, I love the idea of threat model as code because when you make changes, then it just pops up and you can just change the code. So that's very cool. Or you could get one of the community versions of one of the commercial tools. I've listed a couple here. I don't have any I don't have any financial interest in either of these tools. I'm not pushing them. I think they're both great. They're both slightly different. And the owners of each company are dear friends of mine. So, disclaimer. And there's a couple of newer tools that are not in this deck that are out there, commercial tools. So, there's a lot of interest and a lot going on. You start with a tool. One of the problems I see with the open source tools is a lot of times it finds a lot of stuff and that can be very overwhelming. So I find that you usually have to then sit down and say, okay, what's important here and what's not, which ends up being some human analysis. So I don't think these tools are actually going to get you over the hump, but they will certainly get you started. Another couple of resources around attacks. There's MITRE's Attack and Defense. I love this tool. And indeed, I was the very first person to go to them and put it in a book and say, you could use these to figure out tools. I saw and I started working with the MITRE people working on attack very early on, right as soon as I learned about it and thought about it. So maybe, a number of years ago by now. Very powerful tools. It's a bit overwhelming, but at least it might help you see various things. And the other thing you can do is, okay, I'm thinking of using encryption. What attacks does that prevent? And defense has a ontology that goes from each defense back to the attacks it prevents against. So that's very cool. Usually CWE and KPEC are way overwhelming and way too detailed. but at least they have some top level categories that can help you think through things. So this is a list of things that can really help and get you over this attacks problem, and use them. As to defenses, again, same things. Just look at the things, at these resources from the defense perspective. And like I said, MITRE's defense is fantastic, and it can tell you which attacks each defense guards against or helps mitigate or prevent. Or, I mean, yeah, defense is a whole science in and of itself. Just remember, as I said, all software fails. Risk and priority. Yeah, this is a hard one. It's one of the big stumbling blocks. And I wish I could, hand you some cool, easy thing. I mean, me and Vinay Bansal invented just good enough risk rating in 2007 and 2008. It's pretty venerable. It's based on factor analysis of information risk, and I offer it to you. It's the latest, not quite the latest version, is in my last book, Building in Security at Agile Speed. So you could get that, or you can go to my website and look at some of the papers about it. Some of them are pretty old by now. But some technique like that, doesn't have to be that one, is what you want. And this is going to be a place where you might have to do some study. Nobody's going to solve that problem. What are some of the big problems that happen? This is the most often quoted problem that I get from talking. And I'm very lucky. I get to talk to security architects from all over the world on a regular basis. And this is the most often expressed problem: the late threat model. And worse, after the design is complete, that's terrible because it's part and parcel of design. And by then it's just going to mean rework because you're going to find things you need to do. I don't know why people wait until the end after the design is completed to do the threat model. It's completely wrong, but people do. And developers hate it too. If you're a developer, don't you just hate getting a whole bunch of security requirements after you're almost done? I mean, that's absurd. I will remind everybody on this call that you can solve this problem, and you have the power to solve this problem. And I have solved this problem at a whole bunch of companies, by the way, but it wasn't because somebody made a mandate or wrote a rule somewhere. You have to take responsibility for getting your security requirements early. And if you need help with that, engage early. You know they're going to be there. And so if you design software or you code software, be proactive. And if you're a security person, you can reach out to your developers and say, what do you got coming? What's coming up? Instead of sitting and waiting for ET to phone home. Yeah, everyone on this call can solve this problem. And it is the only way I have ever seen it solved, by the way, is by people being proactive and just reaching out and saying what's new and what's the security. And in fact, I want to point out, remember my little horrid diagram, that it's a continuous activity. So our threat modeling needs to be iterative, and it needs to be refined. So once you get a threat model to what you're building, you're just refining it all the time as you make changes. And one other really important thing, and I don't remember who told me this, it's not I didn't originate this, but it's profound. That is, your testing regime proves or disproves your threat model. So I'm always refining my threat model based on the results of my testing. Again, lots of code, lots of shared goals, and lots of interaction, lots of feedback about what's happening in other processes. So the threat model improves because of the testing regime. And you figure out, yeah, oops, we missed that one. Oh yeah, we got that. That's good. We proved it. Yeah, they couldn't get in because our controls were strong enough. Good. It's a matter of refine, revisit, and review. When to refine and revisit and review? Structural change. new components, new flows, new data exchanges. If you have security items that come up, it's a good time to make sure that the threat model reflects those, because it's going to change them. Like, somebody has a new requirement, one of your customers says, no, you need to do XYZ for us, then that's going to change your threat model most likely. And when there are new attack methods, they don't come around, like I said, very often, a couple times a year, but you should see if they're relevant for your threat model. So somebody has to be watching that, unfortunately. And some of the commercial tools do this really well, by the way. Not that I'm selling them, but they do, they try to. Or if you have no existing threat model, today is the day to start. Can we automate? Absolutely. So this space has really matured. In 2015, well, I wrote the book in 2014. Actually, I wrote the book over 8 years, but when I really got it going, it was 2014. There was one commercial tool, and it was really new. It was in version 2 or something, and that's Threat Modeler. And I mentioned it in the book because I thought it was so important. Today, there are a bunch of tools. A couple of them are really mature and way like 9, 10, 11 versions already. They've added tons of stuff. I'm not going to go into those, and they have slightly different approaches, but they're really matured and they really handle a lot of what we normally would do in a threat model. They certainly handle all the basics. If I never have to tell a web programmer that they have to escape their inputs to avoid cross-site scripting, I would be very, very happy. And there are tools that do that very handily. So why am I saying it? Except that I do. But there are tools that do that, and they do that very well. They will cover the basics. What they won't cover is the unique, the innovative, the very, very complex. So you're still going to have to remember that question, can't we just automate all security? I'm sorry, you can't. If you're doing something really new and really different, you're going to have to threat model it by hand, because the tool isn't going to know what to do with that. But they can handle all the typical situations. So there are tools, they can be. There's a bunch of open source stuff that's really good, Venerable TMT. One of the cool things that I think appeared many years ago, I think I first thought about it in 2012-ish, is the idea of just doing your architecture as code in one of the graphing codes. And then if it changes, you can spin a threat modeling task. And there's a couple tools that will do that for you that are watching that. But it's a very cool idea, I think. It's too bad not very many people do that, but very cool. But these are actual threat modeling tools. There are others. These are my favorites. These are my absolute favorites. The others, I think, tend to be toys. So you can draw in a tool. Well, you can draw in a lot of tools. I'm not sure that really helps that much if you have to put in all your own threats. What we want is something that gets you over the humps. Remember the humps I said? Something that can help you with attacks, something that can help you with defenses. Yeah, and these tools are all real. So, the problem with the open source is they're a lot more difficult to use and get working. So you're going to have to spend some time at them. But they do exist, and I encourage you to use them. These tools are helpful. They do various things that might be useful, like Threat Playbook, I think, is the one that does something around checking to see if your architecture's changed and then spinning off, or your threat models change and spinning off testing regimes around that. There's a lot of cool tooling here. I encourage you to get out there and explore it. And it's all pretty DevOps friendly. Just to end here, and thank you very much for letting me blab for 40 minutes at you. What is never effective is beating people up. I have never seen a software security mandate do anything, because we're talking about people who have to do things and have to want to do things and see the importance of it. So for the security people, especially, mandates are important because they set expectations, but they don't actually solve product security or any security problem that I've ever seen. You know, this is something that James and I said in our last book, and it's worth maybe quoting. Software security cannot be imposed. It can only be earned through the inspired and driven efforts of many people from lots of different roles and specialties working together towards the common goal of building enough security. So I leave you with that. Start now. You already threat model. Everybody on this call knows how to threat model probably. Practice, build skill, use the public resources, iterate to stay in sync and to be a part and parcel of the process of building, planning and building software. Automate wherever you can, especially the well-known. Save analysis for the tricky and complex. And whatever you do, it's going to require continual care and feeding. It's not a set and forget thing. I'm sorry. Software security is just simply at its state of the art, not set and forget. Okay, it's done. One and done. No. One thing I will say in closing is if you want to LinkedIn with me, I'd love to link with you, but remind me you were at this webinar because I get a lot of invitations and I don't have time to go and see if they are all real people. If I can only find that you have a LinkedIn and no other presence and you don't tell me, and I have time to go do that because I get 3, 4, 5 invitations sometimes in a day, I won't, and I'll just ignore it because I don't have time to sit there and do that. And I don't pay somebody to do it for me, to be honest. I do it myself. So, you know, just remind me you're at this webinar and then, yeah, we're good to go. Questions? Did anything come up? This deck, by the way, will be available to you, and there's a whole bunch of resources at the end of it for you to check out.
Indeed, there are some questions. Thank you very much, sir. We'll get to the thank you note at the very end, but for now, there are a couple of questions that I see. Number one from Julian Sanchez. The question is, in your experience, what is the best open source tool to do threat modeling if we are starting with this topic in the company? That's the first one.
Yeah. Okay. I think either TMT or Thragile, because they're real tools. PyTM requires some knowledge and you got to have coders and everything. And is that the Julian Sanchez who works for the Cato Institute and whom I follow on Twitter? I'm just wondering. Brilliant. You are so funny. If it is, some of the stuff you post is just delightful. Anyway, let's go on. But those two I think are real, which is why I put them at the top. Either one, or get both, or alternatively, get the community version of either Arius Risk or Threat Modeler. They're going to be a little bit more dense to get started with, whereas Fragile and TMT are totally obvious. You draw your thing and you start getting results right away. And when I was at McAfee and TMT became open source, the people started with TMT a lot, and it really helped them get over the hump. Not that I have any financial interest in it or anything, whatever works. But yeah, I hope I answered.
Thank you very much. And I'll voice over the next question as well. This is from Brijesh. What is the role of attack tree analysis and threat modeling?
Okay, attack pre-analysis. I feel like that is critical for me. It might not be important to someone who's a developer and just wants to get their threat model and just wants to know the correct attacks to apply to their technology. That might not need to be, they might not need to dig so deep. But as someone who believes they are a threat modeler and a practitioner, I need to understand what attacks do and how they work in a computer science sense. In other words, I don't need to know the bits and bytes of every RCE remote code execution in the world. I don't need to know that. I don't. I've walked through a lot of them over the years when I did need to know, but I don't need to know. I need to know that there's something called an RCE, and I need to know basically how those things work in various contexts and what kind of weaknesses allow them. And that kind of analysis can help you be a much better threat modeler. And I encourage you to do it. And that's where something like attack, which wires back to CWE, which wires back to KPEC, by the way, they're all connected, can help you understand those details. So let's just take the classic buffer overflow. You don't need to know every bits and bytes of every buffer overflow, and they're very specific to each situation, by the way. But you do need to know the basic mechanism for a buffer overflow if you're working in a language that can have those, which most of our modern ones don't. But if you were and handling memory, then you'd need to know what various kinds of memory manipulations are at the level of working through one example. And that's very important. So that's what I hope I mean by attack pre-analysis. And by the way, I've done a lot of that. And when a new attack comes along, I get down to the bits and bytes to understand. I was standing right there when Spectre and Meltdown got exploded on the world. I think that was 2017. Immediately I started digging into exactly what does this mean and how does it work and what's speculative execution and what are the caches in the parallel processes of the CPU and really got down into the bits and bytes of it all in order to understand. Yeah, sometimes I have to do that. And in fact, I tried to write in Secrets of the Cybersecurity Architect, not that I'm selling my books, I only get a couple bucks a piece, so it's not that big a deal to me, but just to tell you, I did tried to show you how you do that kind of analysis in chapter 3 of Secrets, because I wanted practitioners to understand sometimes you have to go to this level to really understand what a thing is and how it works, and then you can do your risk analysis because you really understand it. I hope I answered your question.
You did. Thank you very much. And Brijesh has a follow-up question, but there are other questions, so we will circle back and then pick up the other question from Brijesh. There's another one from Justin Walker. How can we expect future threats that are going to come when we start a fresh threat model? So how can we expect future threats when we're going to start a threat model?
That is a key question, and thank you for asking, because it is so important. I'll tell you what I do, which is perhaps not, is perhaps stylistic or aesthetics, my aesthetics, but I'll tell you what I do. When I get a new piece of or a piece of technology that's new to me, I have to do a bunch of research. And the first thing I type in my search engine is security, name of piece of software, name of technology, just to see what other people have written, a security incidents piece of software or technology, because it requires research and I don't always know. And then I try to figure out, once I get a sense of the sorts of bad things that have already been reported, and CVE, the NVD database is a great place to go, even though, like I said, 75% of them will never get used. It can show you the sorts of things that have been reported against a particular piece of software. And more than that, it can show you distribution and frequency. If RCEs are being recorded against a piece of technology once or twice a year, what do you think the likelihood is that, even if you don't have any right now in your software, what do you think the likelihood is that in the next couple of years, at least one will get reported? Yeah, Probably, right? If they're recording, if they're coming in at once or twice a year, probably more than one over the next few years, maybe even as many as once or twice a year, one of which or more may be relevant to my particular context. So I go to NVD and I look at the frequency and distribution over time, because that helps me. While it's not exactly probability, in the absence of actuarial tables, it's something, it's data. It's important data. Another thing to do is to go and check EPSS for any particular issue and see if it's been used or if it's been included in exploit kits. And that's one of the data points in EPSS, which is there's a calculator up on first. And so go there. That's another data point. So I do all this research to figure out what has been happening to this technology in the past. And then by looking at a frequency and distribution, I do a back of the napkin calculation as to whether, and I try to be really conservative. You know, if things show up twice a year, I'm not going to say they're going to show up twice the next year, but I'm going to say over the next few years, you're going to have an incident. So I try to be really conservative about that. And then, you know, you have to decide what you're going to do about it. If the execs look and say, I don't care, we're not even going to be in business next year, well, I'm done. I've never heard that, by the way. But, you know, there's some business driver here that has to be taken into account. But that's how I start doing this, is I go and I find out what's happened. It's just hard research. I'm sorry. It's not easy. It's not like I can't give you the book and say, here it is. I wish somebody would write that book, by the way. I've been asking people for years to do it, but yeah, I don't want to write it. Next question.
All right, there's four already, so I'll go one by one. Arshik Jaspin, or Yaspin, sorry if I'm pronouncing her last name incorrect, has a question. With higher adoption of Agile-driven development, do you think threat modeling with architecture diagrams as a reference will stay relevant?
Yeah.
Okay, great question.
Great question. Great question. I'm hoping that the automation, the tooling is going to come along so much that we reserve plain old architecture discussions looking at a representation for when it's really necessary. And that let me say, and this is hopeful and maybe not real, but I'm hoping, praying actually, that people realize there are resources out there and they can get a lot done with technology, and they don't all have to be experts and spend their lives becoming an architect. Let me just say that. Nothing against architecture. I'll also say at the same time that I'm going to be teaching digital architectures this fall. That's my course at university. I always teach one class at university every year. And it's digital architecture. And my first lecture goes into the history of architecture a little bit. It goes back at least 5,000 years, because we have the plans and the discussions of them to look at. So I don't think humans are going to stop drawing representations of things that are too complex to hold in your mind and talk about easily in language. I don't think we're going to stop that anytime soon. And remember, every tool that helps us solve difficult problems digitally was once an idea that someone did somewhere on the back of a napkin, probably. So I don't think we're going to lose architecture as a discipline anytime soon, nor should we. On the other hand, I hope it's limited to where it really matters. So there's nothing wrong with people getting together and saying, I'm thinking of doing XYZ. Here's a representation of it, and what could go wrong, including security, and having that discussion. And then, you know, moving towards more automation and more tooling that helps us get the universe of it. On the other hand, as the discipline of threat modeling is done this way, I hope it goes the way, I hope it gets reserved for problems that it require that rather than being thought of. I mean, some people, I mean, this is really important for all of you to think about. Some people equate threat modeling with a data flow diagram. The data flow diagram is an architectural artifact we might use for threat modeling. It's not required, by the way, but it certainly isn't threat modeling by any stretch of the imagination. Did you ever draw a data flow diagram about driving? Let me go back to my example there. I think probably not, but you have a threat model. So yeah, the two are distinct things, and one is a tool, and we shouldn't mistake the tool for the process. I hope I answered your question. Yeah, we're going to keep doing it, but I hope it's not all the time, and you know.
Thank you very much. I'll add a little bit on top of that. There are some tooling advantages to bring the architecture diagrams as close to developers. For example, threat modeling as code tools through Agile, PyTM, or Plant UML tries to address the changing architecture diagrams, but like Brooke said, you still have to think about an architecture diagram or draw it in a whiteboard or on a piece of paper before you start updating the actual code. Problems always there.
Can I throw in, Maren, that if your business has a requirement for proving you a threat model, you probably have to document it in some really, really decent way. But if your business doesn't, and you just want to prove that it was done, taking a picture of a whiteboard is a perfectly reasonable artifact that people can refer to. And you can even put a big image of it in this daily stand-up so that as things come off the backlog, people can say, does this affect the threat model, or can we just move on? Oh, I think this got security. Oh, I think it's more than we have expertise in the room. Let's get a security expert in the room. I mean, this was something that my friend Owen Carroll actually did just on his own, just hanging up the threat models. And he used to do the most beautiful threat models, by the way, in Visio, with multiple layers and stuff. They were really quite amazing artifacts. I generally have time for that, unless people pay me a lot of money. But just putting up an image, and he put these images in every stand-up, caused organically everyone to start considering security as they pull items off the backlog. It was brilliant. It was amazing, and shifted my own understanding of the threat modeling process a lot. Just that, watching that unfold organically. So yeah, make it available to developers. Why not? You want everybody to have at least some threat modeling capability because they're all writing software.
Indeed, thank you very much. And there's another one from Preeti Sampath. Is it necessary to do threat modeling, even though we have robust SAST, SCA, DAST, and pen test programs?
Yes, they only find what's current. They won't build those security features. They won't design for security. Yes. Unfortunately, those things, all of those are about implementation errors or missing. Some of them deal with design stuff. For instance, DAST will find that you haven't, for instance, put some protection in, say a nonce or whatever, if you need to do state, and your state can be misused for like a cross site request forgery or something similar. And so, yeah, they'll find some of those things, and those are design issues. Sure, it's true, but it's very limited. And that only works if you're working in web programs. And what if what you're building has no web components whatsoever? Then most DAST tools are going to do nothing for you unless you're fuzzing. And do fuzz, please fuzz. Software security is a lot more than threat modeling. But software security is a lot more than testing. Software security is, again, multidiscipline. multivariate, multi-domain. And no one thing is going to get all the problems. The only way you can design for security and build the right stuff is if you think about security as your building, not as your testing. Though thinking about security as your testing is also critically important. I don't want to overemphasize the importance of threat modeling. It's one thing in a kit we have, but it's an important thing, just as the tools that the questioner mentioned are also important. And may I also say, and this has nothing to do with threat modeling, if you're relying on one tool, you haven't got enough. I'm sorry. No one tool can do it all, despite what vendors claim in their marketing. No one tool can do it all. So if you don't have several different approaches that you're using in your testing regime, get them. That's my software security talk, and it's a different talk. But yeah, next question. I hope I answered.
All right, thank you. You did. Yeah, thank you. The person who asked the question says, appreciate the detailed response. There's another question from Preeti again. It says, threat modeling provides potential threats and possible mitigations to address them. How do you quantify the results from a threat modeling exercise?
Another terrific question. This is very hard. There's a couple of different aspects. The first part of it is just dealing with the threat model. That's what the risk analysis is about. And again, I didn't go into those techniques much here. I gave you a couple of pointers, come to a different talk, write me offline. Let's start a discussion on LinkedIn or some other platform. Yeah, I'm happy to have it because it's important. But that's what the risk stuff is supposed to do for you, is supposed to help you solve the problem of what's important and what's not important, because some of the stuff you think of won't be important. And by the way, you're done with the threat model when you start making up attacks and you get into science fiction. You're done. We don't have to do that. Stop there. Fun as it may be, entertaining as it may be. Well, if this went wrong and I moved this special needle that's never been done before over here, could that be an attack that then we have to? Yeah, you're done. Do that over your beverage of choice, after work, but you don't need to do it at work. Having said that, figuring out whether the threat modeling is effective is a very, very difficult problem at today's level. And measuring requirements is not the way to do it, in my opinion. Because if a team are really good at security and they actually have already thought through most of the problems, even if they haven't thought of it as threat modeling, and there are no additional requirements, is that a failure? I think that's a wild success. In my programs, that's exactly what I want. I want developers to put me out of business. I want to become redundant to everything they're doing. Then I know I've been successful. That's not a good measure. And I've struggled with this for decades, by the way, because I became Cisco InfoSec's very first application security architect in early 2001, very first. And I then led what did eventually become the biggest team in Cisco InfoSec. And so I've struggled with this for a long time. It's not a simple problem. There's a couple of things. One of the things I use to see if my architects are effective, and it's very woo, and you might not like this, but it works, is if people are being invited to the meetings, that's a very good sign, because development teams are really good at disinviting people who are disruptive or don't add value to their process. They're really good at just going on with meetings, hearing once, and then you just never hear about what's happening next. So if my architects, the people I'm working with, get invited, if they're seen as valuable, that's very important. Very important. That's the first indication that your program's being successful, by the way. On the other hand, that's not a very good measure. How effective? Well, the worst thing is, how many requirements did they write? Because sometimes things are complicated and sometimes they're really simple. It's a useless metric. But I will tell you what I've come up with. And it's very simple. It's a bit hard to gather. How many requirements that are specified actually get built? That's a measure of effectiveness. How many requirements that have been identified actually get built and released? That's a measure of effectiveness. If your threat model merely sits on the wall and people don't actually build anything that you came up with, that's a really ineffective threat model. Why did you do it? But if people have built the stuff, some of the stuff in the threat model, that's a very good sign that it was valuable and that your security posture is moving in the right direction. So I offer that up. It's also in a couple of my books, but I offer that up as a really good measure. It's a little hard to capture, but it can be captured because I've done it. Or my teams have done it. I shouldn't say I've done it. I said, let's do this, and then we figured out how to do it. I mean, you know, all of the things when I say I mean like groups of amazing and brilliant people. Because threat modeling is a team sport. In fact, software security is a team sport. Next question.
All right, probably the last one from Udit. What is your recommendation to do threat modeling on developments if we have to use dependencies like Kubernetes, which we don't control, especially when there are shared responsibilities at play? How do we do that?
Yeah, so this brings up a couple of really interesting questions. Buried in here are some implications. Many teams, when they do their threat model, forget to threat model the build chain. But software security demands we look at our build chain, just as we look at our external code dependencies, just as we look at the entire tech stack, and just as we threat model what we're actually building, as opposed to the things that help us build them. But importantly, implicit in your question is that you're threat modeling the build chain and the deploy chain. Good on you. You must. So that's the first thing. When you say we don't control, that's an interesting statement. I can take that in a bunch of different ways, and maybe you want to refine that for us, but I'm going to just spin anyway because I'm talking. And I take a couple of different cases. One case is some other ops team has the build chain, and have they threat modeled the build chain? Well, I would go to whatever execs. If I couldn't get them to answer that question, personally, I would say that's a risk that I can't leave on the floor because that's what I get paid for. And I would go to whatever execs and say, they're not working with me and I'm worried. What's the situation here? Should we all be worried? And I would raise that risk, even at the risk of getting fired for it, by the way, because it's too important to leave on the floor. So, you know, if you have an ops team who refuse to talk to you, that's a problem. That's a big problem. And may I be so bold as to suggest maybe you should start looking for a different organization to work with where people know how to work together. Because like I said, it's a team sport. But nevertheless, that's one way I could take your question. And you want them to threat model it. And they could be responsible for that. That's fine, as long as they do it. And as long as you can prove the provenance of your software, that what you built is what actually got released, what you intended is actually what got released. All of that's really important. And if you have B2B customers or government customers, they are going to require you to give them your provenance. So yeah, that's all. Problem has to be solved. But I'm also going to take another implication from the question, which is you're using the Kubernetes in something like, you know, GCP, or it's provided by Amazon or your cloud provider, whichever one you use, Azure or whatever. And that's a different question. You need to threat model the accesses to be sure, but you don't have to threat model the tool because the cloud provider has already done that. You are counting on your cloud provider to provide the security for that tool up until the point where you use it, and the code you put into it and the accesses your team have in the tool. But its basic provenance and security are not in your responsibility, nor should it be, and you are counting on your cloud provider. And I might note that at least the big cloud providers have a business interest in doing this well. Again, all software fails, so they're not going to do it perfectly, but they do have a significant business interest in doing this well, and you can twist their arm if they don't. I hope I answered your question. There's a lot of different aspects to that.
All right, well, was the last question. I did have one, and hopefully we have time for that one last question. What was that? Is CVSS a severity rating? Could you tell apart the differences between quickly severity rating versus risk rating?
Yeah, sure. Great question. Thank you for asking that. And they're all great questions. And thank you for asking and playing with me. And just to be a little disclaimer here, Cisco was one of the people at Cisco were helping build CVSS in pre-version 1. And we piloted it and beta tested it before it ever got released in Cisco InfoSec. So I've been kicking around CVSS for a very, very long time. So hopefully I understand it and understand how it works. No way, I want to be really clear before I answer that question. No way am I saying we should get rid of CVSS. It's a very important tool. It is misused. That's the problem. If we would only use it for what it's for, life would be good. But we don't actually have good replacement. And so people have overused it in places where it wasn't meant to go. If you go up to the CVSS documentation, it will say it is a potential severity rating. I think that's a direct quote. What that means is, in an ideal world, without taking in any other factors except the factors of this vulnerability, and assuming, which is completely incorrect, that all vulnerabilities are equally attractive and usable to attackers. This is provably not true. I wrote about this when I was at McAfee in 2015-ish, I think, or 2014-ish. So you can go look, that post is still up there. Please go look at it. I've written about it multiple times, but that's probably the best analysis of why that's true. But nevertheless, in the ideal world, if the attacker has everything they need, how bad could this be? That's an important measure because it tells me whether I should pay attention or not. So that's what it was intended to do, and that's what it does. And it's been revised to be even better at doing that. Now, where are the limitations? One, CVSS assumes that all vulnerabilities are equally usable by attackers and will be equally valuable. That is a bad assumption. As I said, only 25% and maybe even less, depending upon which research you look at, of what gets reported is actually used by real world attackers. So a lot of it is dross. So apparently a lot that gets reported isn't useful at all. We have the data. We know that for a fact. So, you know, CVSS isn't going to tell you that. It doesn't have a mechanism for telling you that. I actually proposed some years ago to first a mechanism for telling that, or at least refining that problem, and they ignored me. So, you know, shows you how important I am. But there are ways, and I have them in my books that you can go look at, blah, 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 that you know, can help you refine CVSS and get better with it. But yeah, vendors who produce software are not allowed to use environment. If you use the environment calculation, it helps a lot refine context, but still there's a lot of context that's missing. So CVSS isn't risk. It's about what would happen in the kind of ideal space given very generally. And by the way, Alati and Masaki in 2014 have this brilliant piece of research, and a lot of research confirming their research, by the way, since then, that says using only CVSS based score is basically about the same as choosing at random, which is how you get a very mature cybersecurity function at Equifax getting blown away, and they're still playing. I think it's up to 1.2 billion. So yeah, that's how you get those situations. They were using CVSS as their risk score. Yeah, don't do it. So in the absence of that, I've made some proposals. A couple of other people have made some proposals. There have been some things that haven't been adopted at all. The thing that Vinay and I built at Cisco in 2008 has been used by a couple of companies now for decades, and it works. It's not perfect. It's something. So risk rating is, importantly, in the absence of actuarial tables, which we don't have, not broad actuarial tables. We have some discrete ones. Go look at the Poneman Institute stuff, but we don't have really broad ones, and across all different kinds of compromises and attacks. Without that, we have to do some very funny things to come up with a real risk. So the difference between real risk is you have a probability that you can mathematically support. And the math we use, and this is what factor analysis of information risk uses, is casino math. And you run many simulations after you define the variables, and the bell curve begins to give you a probability. It's very interesting theory. And I invite you to go look at that and go look at factor analysis, or FAIR as it's called. It's an open group standard. My friend Jack Jones invented it, and I just happened to be around Jack through happenstance while he was working on it. So I got very lucky there. And everything I do is based in that because I think it's really solid. But setting up those runs and the math is not easy. Okay, so what do we do instead? We use risk rating. That is something that is akin to risk that has data behind it, that we can get close to a probability and substitute probability, substitute something else for probability, generate a number between 0 and 1 that can be used as a probability, and then multiply that against however you rate your impacts. And that turns out to be something fairly easy and trivial to do. But the probability is the hard one. And that's why I call it risk rating and not risk. It is not risk. Anything I tell you to do in these things is going to be risk rating, because it's very hard to do risks unless you're going to do something like factor analysis of information risk, which does actually calculate a probability. So that's the stumbling block we have today, is we don't have actuarial tables. We have to do some significantly difficult math in order to get probability. So we have to do something else that kind of substitutes in a reasonable way. And by the way, Jack looked through what I wrote in Securing Systems. I had him review that chapter, and he said, "You're good to go." I did make every change except one that he asked me to make, by the way, in that chapter. So if you want to look at something, go look at Securing Systems or its subsequent books to see. It's basically an update of Jaeger, though. And that's why I mentioned it, because it's on solid foundation. But you have to do something like that, ultimately. Just guessing isn't very good. I hope I answered that question. It's a very deep subject and a very difficult subject.
You did. Thank you very much for answering that, sir. And I also realized that you've been talking with a lot of energy for about 90 minutes now. So I'm going to share some of that load and perhaps wrap up the webinar here. There are some interesting things that I would like to share with you and the rest of the participants. There was a slide on which attackers, where you have detailed a list of tools in the order of TMT, open source, and then followed by commercial tools. Coincidentally, I did a podcast with somebody last week, and I did the exact same tooling in the exact same order. I said, well, open source and then community edition of those two tools. I was very delighted to see that. And then,
virtual handshake, fist bump, right? Virtual fist bump. See,
Thank you.
I'm not full of BS, because if Maren says so, then, or we're both full of BS and you don't have to listen to either of us. But no, those are the tools. That's the best tooling that we have, as far as I know. There are a couple of new entrants, by the way, commercial entrants. I don't know if they have community versions or not. I haven't looked at them. I can't say anything about them. But this market is building, which is really good.
Yep, and another one, I don't normally do this, but then we at Practical DevSecOps have authored a new self-paced course on threat modeling. It's called Certified Threat Modeling Professional. We cover a lot of these tools. You can experience these tools right within our Cloud Labs portal if you're thinking about tooling. And a lot of these things that Brooke discussed today are also discussed in the course. And on top of those, the different things that Brooke referred to are also discussed in the course. Check that out, and I'll leave it there. With that, there are a couple of interesting points that I've picked up, and I would normally like to share these things at the end of the webinar, and they're very interesting, and I find that interesting. But before I get there, the webinar is being recorded in the YouTube channel. It will be available. The name of the YouTube channel is Practical DevSecOps. 2 words. Practical is the first word. DevSecOps is the second word. If you subscribe, you will get notifications there. With that, what are some of the codes that I picked up? Encryption is not peanut butter that you put everywhere. So that's something that was very peculiar. And another one, very thought-provoking. Did you draw a data flow diagram when you drove a car? Right? So when you tried to drive a car and you perhaps thought about the threats, did you draw a data flow diagram? No. So that implies that data flow diagrams are useful in visualization, but they're not an absolute necessity. Here's another one about tools. What benefit is a threat modeling tool if they help you draw diagrams and if they help you add threats? Well, the phrase emphasizes that threat modeling tools need to have automated threat building or threat generation capabilities. So that's important there. Here's another one. If you are security, go to development teams and talk to them, understand what's coming up next, instead of ET phoning home. With that, I'd like to thank Brooke for being our guest today. And I'd also like to thank all of the attendees that have stuck around since the beginning until now. It has been absolute wisdom and very detailed, eye-opening answers. So we'll get in touch with you again, and hopefully you are willing to come and present with us again.
Absolutely. Absolutely. And
Right.
thank you so much for attending and listening to my blathering on for so long. But hopefully there were useful things in here that actually improve your practice. That's the thing. Software security is hard, unfortunately. And because of that, every little trick counts.
All right. The next DevSecOps Live is on September 8th, 2 weeks from now, approximately. So stay tuned to our LinkedIn channels, and then we will post updates about the next webinar. Also, the recorded session will be available there. Having said that, thank you very much, everybody, for joining today. Let's give a virtual round of applause to our speakers. If you want to use thumbs up or smileys and emoticons, please share them. It'll be nice to see some of those. Thank you very much. And until next time, have a good night, good evening, and enjoy the rest of the day. See you later.